In this tutorial, we will be talking about groups. So I am logged in, I have a session running for me, I have a loaded engine, molecular_THF, so the groups menu tab here is activated and I can go and check it out. When you look at this web interface, you have two main sections. The middle one, where you can interact with the engine to clear groups or to set or add the groups that you want to define. And the right hand here is where you have the current status of the engine with the groups that are already defined and exist in the engine. The list of groups are in this list here, and in total we have 9,490 groups defined in the engine. You can cycle through those groups one by one, and you can see the index of that group in the engine by reading this first number here, and by selecting this group you can read the information that these groups provide. For example, this is group index 9. The class of that group is group. Obviously, you have two classes of groups. You have group and you have empty group. And we will discuss more what an empty group is when we get there. You have the name of that group. This is given by the user or by full RMC. If you specify the name, it would be the name that you specify it, or it can be given automatically by full RMC. So full RMC itself doesn't make use of the group name as is, but this is a very important property for the group that you will be using in the generator section here to help you select groups easily from the interface, so you can, for example, select of groups that you want to attribute some move generators to those groups. We will get to that when we are looking into that generators tab. So also you have the number of atoms that are defined in the group. Here it's 1, and you can see it from here. So the group index 9 has only the atom index 9 in it. And you also see the move generator that is attributed to this group. In this case, it's translation generator. You have the list of elements, capital H, and the counts of those elements, and the list of atom names, which is, for example, in this case, capital H 32. And the count is capital H32, a count of 1. So the elements and the atom names are exactly what you have in the PDB file you provided to full RMC. So if the element is lower h, here you will have it as lower h. So it's whatever you provide, you will see in here. So let's go first and describe in a few sentences what the group is. Full RMC do not deal with atoms. Full RMC deals with groups of atoms. So when full RMC's engine is running, it does not select atoms, it selects groups of atoms, and a group of atom is nothing else but a set of atoms indexes that exist in the engine. And I chose the word set here because you cannot have redundant atoms in the same group. You cannot have, for example, atom 0, 0, and 1 in the same group. That full RMC would not let you do. But you can have as many atoms as you want in a group, and the same atom can be defined in different groups. That's okay, that's perfectly fine. But in the same group, you cannot have redundancy in the atoms. So again, a group is a list of atoms indexes, a list of unique atom indexes, as simple as it gets. And upon those atom indexes, so upon those atoms, when the engine is running, the groups will be selected by the engine selector. So when the group is selected, now a move has to be performed against the atoms in that group. And the move will be created by the move generator. So this is why the groups here sits in the middle. The groups are selected by the engine, then moves will be applied to the atoms of that group using a move generator. So an atom, a group, needs a move generator. And by definition, by default, every time you create a new group, the move generator for that group would be a random translation. That's why you always see here translation generator. You can change that in this tab. We will get to that. So the first thing you need to notice here in this interface is the first section here, which is newly defined group's name. Anytime you need to create or add, or to set or add groups, you can give a name that would make sense to your creation. or you can let full RMC define it for you. So if you leave this empty, full RMC will try its best to choose the best name that fits the groups you created. For example, if the group has one atom, the name that full RMC would give it is atom. If the group has many atoms in it, the name that full RMC will give it is molecule, for example. And if you build the group using the build groups function, which we will also explain later in this tutorial, full RMC will try to give it a name that is meaningful to the filters and the keywords and the group by keywords. And if you do it here in manually defined groups, it will also try to find a name for it. But the easiest thing to do is to define your own name so you know exactly what you are referring to. So first, let's start by tackling this section here. And this section is it exposes full RMC's helper functions to automatically set a group name. So you have create groups of atoms, and this will make use of Engine's set groups as atoms definition. You see it in here, it just disappeared. Let me show it back to you. You see it, oh, it's gonna disappear. Set groups as atoms. And when you call that function, when you call it using the function set that you find here, you click the button set. What set does, it will clear out all the groups in your engine, and it will reset those groups to whatever this function is going to return. So you see set and add in all this interface. Whatever you hit set, what will happen is the currently defined groups in the engine will be deleted or removed, and the newly created groups will be set to the engine. When you click on add, none of the groups that already exist in the engine will be deleted, but the newly created groups will be added to those. So let me now give it a name so we can flag it the way we want. And in those freeform fields, you need to give Atom Python data types. And the Python data types are lists, strings, dictionaries. So here, for example, we're giving a name. It must be a string. So you need to remember this software or this web interface is the engine behind it on the cloud is a Python engine. So whatever you type here, it's going to be interpreted by Python on the back end before it gives it to full RMC. So the data types you need to provide needs to be Python data types, and a string in Python data types needs to be wrapped with a single quotes or double quotes. And you put your string here in between. So let's do that now. You know what? Okay, let's do it first, and then we will see what happens if you do not do that. So here I will say my groups. So whatever groups now I will be creating, the name of those groups will be my groups. If you are going to create 10 groups and you want to give a different name for each one of them, you need to provide a list of 10 names. So here it will be name 1, I don't know, name 2, name 3, and so on, and you provide the list of all the names you want to give. So we are not going to go that far. I'll say my groups, and what I will do is I will set the groups by using the automatic setter helper function set groups as atoms in here. Let's see what this is going to give me. And now the groups are set. I have the response back from the server, and when you look at those groups, I have 9,490 groups created and set, and the group name is my groups. That's a very simple thing to do. So now let me change that group name, and I'll put here my newly defined groups. And I didn't wrap this name by quotes. So I want to show you the error that we will be getting. And instead of setting, I will be adding. I'll add this, it will say unable to perform groups related request, invalid syntax, check logs for more information. Here it says unable to evaluate group name. Make sure it's a Python evaluable expression. So I know that here I need to specify a string, and now I don't want to add, I want to set to show you what add is going to do. Currently I have 9,490 group in that engine. By adding those, it will double. It will be 18,980 or so. And I will add. It will take some time to go back and forth to the server. And here you have it. 18,980 group are defined currently in the engine. The first 9,000 groups, or 9,400, they will be the previously defined groups, and the name of those, each and every group in those will be my group. If we scroll down to the bottom, where the newly specified groups are created, the name of those groups will be my newly defined groups. So this is an example. Now what I want to do is to use the other automatic setter, which is create groups as molecules in this particular example. And full RMC can decipher molecules from the PDB file under the condition that your PDB file is formatted in a way that full RMC understands it. So to see what this formatting is, we will go to documentation. Now we'll go to the question and answer form. You see it here. And there are frequently asked questions. Let's go to the PDB file and see what PDB file is. So this is the PDB file that full RMC understands as an initial structure. I will select those three lines here, and I will go to the molecules. In full RMC, a molecule is a consecutive collection of atoms sharing the same residue name, sequence number, and segment identifier. So it needs to be consecutive collection of atoms. So those first three are consecutive. First row, second row, third row. So if I take those three and those three are not consecutive, they cannot be in the same molecule, as a matter of fact. They need to be consecutive. They need to share the same residue name between column 18 and 20. So I go between column 18 and 20, the orange, the pink stuff here, CO2. So they share the same residue name. They need to also share the same sequence number between 23 and 26. The color is cyan. So it's all one. They also share that. So far we're good. And they need to share the same segment identifier between 73 and 76. This guy here. They are all ones. So obviously those three will be parsed as atoms of the same molecule in full RMC. Now if we look at the next three rows, they share the same residue name, they share the same sequence name, sequence number, and they share the same segment identifier. So those are also another molecule, but they are not to be they are not the same as the first molecule, because the sequence number is not the same between these and these. So you have 1, 2. So I think you get it, and if you don't, you just need to read it again so you understand it better. Let me go back here. So now since I give it a good PDB file, full RMC understands what a molecule is, and now I will go about setting those groups as molecules. Let's see what's going to happen. So now instead of 9,400 something, I have 730 groups in the system, and each group is the name of those groups. Each one of them is molecule. The class is group. The number of atoms is 13 in each one of these groups. And these are the elements, and these are the atom names, and this is the counts of the atom names. What I want to do now is, I have created molecular groups. I also want to create atomic groups. I'll call it here atomic. And I don't want to set these. I don't want to delete those molecular groups. I want to add it to these. So I want in my engine to have molecules that move as a whole using their own move generator. And I want the atoms also to define the structure by moving also alone. So instead of setting now, I'll be adding. So remember, I have 730 groups, and I will add all the atoms, and I'll be in the 10,000 something now probably. Now I have 10,220 groups. So the first groups I see here are the molecular groups. If I keep scrolling down, I have the atomic groups. And I can add as many as I want. The last automatic setter I will talk about is the clear groups. And as its name says, it clears all the groups in the engine. And full RMC warns me that I'm doing that, because an engine without groups is as good as nothing. An engine without group, you cannot run it. If you run it, nothing will move. The system will not even budge. So you need to have groups where the engine will apply moves against those groups of atoms in order for the system to evolve. So we always need to define groups, always. Now let's go and talk about build groups function. From here it looks a little bit intimidating, but actually it's not that difficult. It has exactly two parameters that you need to set: the filters and the group by keywords. So the filters, you need to use it to filter atoms from your system, and against those filter atoms, for example, I want to filter all carbon elements. So I need to specify that I only need to create groups of carbon elements, and against those filtered atoms I can group them to create groups of more than one atom or different sort of grouping. We will give some examples. Let me now start by doing this. So now I want to select hydrogens. Element equal always provide spaces between the keyword and the operator and the value. Give spaces. If you don't, full RMC will yell at you. So element equal hydrogen. Let me put it lowercase first to see what's going to happen. Set. I said that. Well, nothing happened. Well, you need to read the log. The log says add 0, so at frame 0, because now we are using frame 0. All 9,490 atoms are filtered out upon applying this filter. During engine build groups method call, all groups are removed and engine has no groups defined. The reason why this happens, because I don't have lowercase hydrogen in my system, I have uppercase hydrogen in my system. And for me to know the elements I have, I need to check my PDB file or to go to frames and see what elements I have. I have capital O oxygen, capital C carbon, capital H hydrogen. Capital H is not lowercase h. So here it is, and now I will set it. And I created a single group because I didn't group those filtered atoms by something. They all come together under a single group of 5,840 atoms. Maybe that's not very useful in this case. So let me go and do this now. I want to group by index. So also whenever you're not sure what you need to do, you can set the mouse on something. It will give you a little hint or a little help. So here a PDB property, it tells you that a group by takes a PDB property, group by keyword, strings or list of those. It tells you what those keywords are and it gives you an example. And if you're not sure as well, when you remove everything, it gives you examples as well. So now let me group by the index. Obviously in full RMC, every atom has its own index. So when I group by index, I will be splitting all the filtered atoms, each one in its own group. I'll set this. And here you have it. I have now 5,840 groups. Remember, I didn't specify the name, so full RMC tries its best to give it the name it deserves. And here it does it by using the filter and the group by. So index 12, and I go here, index 19. So this is group index 11. The name of it is index 19 because the atom in this group is the atom index 19 in the PDB structure, and you can see where I'm going. So now let me do something else. Let me do element equal capital carbon, and let me specify another, or let me do it later. And here I want to group by the sequence. Okay, before doing this, let me set it. So I have one group. Okay, and this group has 2,920 atoms. I want to now group by the sequence, element equal carbon. And by grouping by the sequence, this group, the atoms in this group, they all have the same sequence number. In this group, they all have the same sequence number. So you know where I'm going. And the name is sequence 11 here because I did not specify the name up there. If I specify the name, the names will be all the same. So now let me do an even more complicated filter. I want to now filter by the carbons, so I want to only consider carbon atoms, and I want to take all carbon atoms that are in the plane, in the X plane. Okay, let's say X between, I don't know, 0 and 5 angstroms. So I am taking carbon atoms that have the X position between 0 and 5 angstroms, and I want to also group in the sequence set. So you see, you have different groups, you have different stuff. Each group has a different number of atoms now because, for example, in this sequence number 52, which is molecule number 52 for that matter here, only those 3 carbons are found in between 0 and 5. All right. So I think that you get where we're going. So you can specify the filters as strings or as lists of strings, and if you're not able to do it in strings, you can even provide it as a tuple, like x, comma, between, comma, -1, 1. You can be as crazy as you want to. You have also the documentation available for you to see how to do it. Now, the next way to define groups is by specifying the indexes of the atoms of those groups manually. So you are not able to do it by the build groups here by filtering. This is not enough for you. You have your own way of doing it. Whatever that is, you can specify it. And here you need to give a list of atoms indexes. And remember, atom indexes go from 0 to the maximum number of atoms in your system. If you go beyond that, if you go beyond the maximum number of atoms, it will tell you that there is an error happening. I cannot do that. There is no such an atom. If you go below 0, it will tell you the same. So here, let me go. I want to create groups of atoms. So I'll take group 0, atom 0, atom 0, atom 1, atom 2, 3, 4, 5, 100. So here, if you see, I specified pure integers, and this is a tuple, and every integer here will be in a group by itself. Let me set it. Set. You have the first group, the atom in it is atom index 0. The second group, the atom in it is the atom index 0. So you see it. And the group name is manually defined because I haven't specified it here. Let me specify it here and give another example. My best groups. So here I want to specify groups differently. I want to say, okay, the first group, it will have 2 atoms, 0 and 1,000 and 100 or 1,000. The second group, it will have 5 atoms, 1, 2, 3, 4, 5. The third group will have 1 atom, 0. And this one, it will have 2 atoms, 10 and 20. Let me copy that. Set. So you see those groups, how they are specified, and those groups' name are my best groups. You see it. Now let me try to set a group that have an atom index beyond the desired ones, beyond the acceptable ones. So I know I have 9,900 or 940 or whatever. So I'll go crazy. I'll put 10,000 and I'll say set, and it yells at me. Unable to perform groups related request. Group index must be smaller than the number of atoms, 9,490. I'll click OK, and this is the log coming from full RMC itself. So the error you see here is coming from full RMC web version, but this is coming from the full RMC's engine. So nothing happened because there is an error. I couldn't set, I couldn't do anything. Let me take this out, and now I want to add it. I don't want to set it. And tuck. You see? All right. So this is how you set groups. Now, the last thing I want to talk about is how to create an empty group. So a group is a list of atoms indexes. An empty group is a group that has no atoms in it. So the list of indexes will be empty. There will be no atoms in a group. So why would you want to set an empty group? It doesn't make sense. You're not moving anything. Well, an empty group is used to try to remove atoms from the system. So to do that, it takes a particular move generator, which is a remove generator. So you wouldn't be specifying atoms indexes. You would only be saying, okay, I want to create that many empty groups. It doesn't make sense to create a lot, so let me create only one. I'll add it instead of removing it. And this is my empty group. You see, there's nothing in it. I will click in it. It says the class is empty group. The name is empty group. The number of atoms is 0. And the generator is atoms remove generator in this case. So I think I've said everything about it, about the groups. Maybe other questions will come along. We will address them even offline or by answering the question and answer forum, or I will do another video about the groups.